Hello students, good morning. Today we will be starting electrostatics. So let us discuss about electrostatics first. It means study of the charge at rest, but definition is not completely correct. Why? Because the property possessed at rest is same as property possessed by charge under motion. It means the property we will study under electrostatic will also be applicable when charge is moving. In this way, so correct definition of electrostatics can be when the charge is under a steady state, or we can say the charge is constant with respect to time. So from here we can say charge does not depends on time. Either this, or we can say Q remains constant. So under this topic we will study the property associated with charge at steady state. That is the first property, force on a charge. First thing that we will discuss. The second point will be the electric field and in continuation we will do electric potential. And the last that we are going to discuss for static charge will be potential energy. So let us start from first point, that is force on a charge, that is Coulomb's law. And that is very basic law which we all have studied in grade 12. So we know this. This law defines the force between two charges. The force between two charges. So the charge may be point charge, surface charge, line charge. So there are different type of charges. We will start from point charge. So the point charge means the charge of a body can be assumed concentrated at one point. For example, there is a spherical body and charge is distributed at it, that is Q. Now for any external point, this positive Q can be considered as the concentrated at point this So in this case, this is considered as the point charge. Or if there are two charges, for example positive Q, negative Q, and the distance between these two is d, radius is r. If r is less than d, again it is considered as point charge. So let us discuss Coulomb's law, that is, force between two charges is, first point that we can see regarding the force between two charges is, first point we can see, directly proportional to multiplication of the point charge. First point we can see. Second thing we can add, it is inversely proportional to the distance between these 2 point charges square. Okay, and third thing, since force is a vector quantity, so it must have a proper direction, and on the basis of that we can say the direction of the force will be along the line joining between them. So we can say force between two charges is along the line joining between them. On the basis of this, force between 2 point charges can be written as, it is proportional to multiplication of the charges divided by the distance between these two square. And to remove the proportionality, a constant k is placed here, and this constant is equal to 1 by 4 pi epsilon for any medium. Epsilon can be written as epsilon naught epsilon r. Epsilon naught is permittivity of medium when the medium is air, and epsilon r is relative permittivity with respect to air medium. And now let us discuss about epsilon itself. How we can define this? If we can define it, then we can understand this is ability of material to permit the electric field. Is it correct definition of epsilon? No. Then what is the correct definition? If we will write the formula, then we find it is in denominator. So that is not the ability to permit, but ability to oppose the electric field can be there. So epsilon can be written as, epsilon means opposition of electric field to pass through the material. Opposition of electric field to pass through the the material. So in this way, according to Coulomb's law, force can be written as 1 by 4 pi epsilon, the multiplication between the charges q1 q2 divided by distance between them square, where epsilon is the ability to oppose the electric field to pass through it. What we can find from here? One thing that should be noted at this point, q1 and q2 must be placed with their proper sign. If they are negative charge, then they should be placed with their sign as well. This is not showing any vector characteristics. For that purpose, the direction of this should be from, it can be multiplied by unit vector in the direction of radius vector, means line joining between these two. The force that we find from Coulomb's law is 1 by 4 pi epsilon q1 q2 by r square. For example, consider 2-point charge. Before that, let us see, this is not a vector quantity. However, we know that force is a vector quantity. So we have to consider the direction of the force acting. So in the previous slide, we have seen that the force will be always along the line joining between these two charges. Suppose there are 2-point charges q1 and q2. They are placed at position vector r1 and at position vector r2. Then the force between these two will be you can say r12 will be in this direction and r21 will be in this direction. Now if we define the position vector, any position vector can be defined as r21 means the final position, r21 the final position is r1, final position is minus initial position r1 minus the initial position r2 with respect to origin. So r21 can be written as r1 minus r2. Similarly, r12 can be written as final minus initial. So if we correlate between these two, then we can find that r21 is equal to negative of r12. Okay, so if we are seeing the force acting on this due to this charge, then we can say force 1 2 will be equal to 1 by 4 pi epsilon q1 q2 divided by r12 square okay in the direction of r12. Hope it is okay to reflect the direction of the force. If we further simplify this, then we can find 1 by 4 pi epsilon q1 q2 r12 can be written as r2 minus r1 whole square multiplied with r12 can be written as r2 minus r1 vector divided by its magnitude. So in this way it can be multiplied and further can be simplified as q1 q2 r2 minus r1 divided by r2 minus r1 cube. This is the force in the direction of q2. Okay. Now similarly find the force at this due to this one, then it will be F21 will be equal to 1 by 4 pi epsilon q1 q2 divided by r21 square, and the direction is r21. Now if we simplify this, then we can say that q1 q2 by r2 minus r1 cube, r1 minus r2 cube. By the way, both will be same because we are taking absolute value, and r1 minus r2. So in this way what we can observe, this can be written as 1 by 4 pi epsilon q1 q2 r1 r2 and r2 minus r1. Relate this with this one, what we can find, F12 and F21 both are of opposite nature. So what is this? This is Newton's third law. I think you can recall. The force acting on a charge are always equal and opposite. Equal and opposite. That is, in another way, there is every action has equal and opposite reaction. Every action has equal and opposite reaction. Now if we are considering the set of the charges q1 and q2, both these charges as a system, then force will be only internal force and the net force will be 0, because it will be force acting on this, from this will be in this direction, and from this will be in this direction, if both are of same polarity. And if these two are considered combiningly a system, then both the forces equal and in opposite direction can be cancelled out. So the internal forces will be only there, and the total force on the system will be equal to 0. So we can write, so for any system, for a system the electrostatic force will be only internal forces, and the net force, net means total force of the system, net force will be 0.